In this example, we are going to look at the leveling run from benchmark 1 to benchmark 2, and you are required to observe the elevations of point A, B, C, D. We need 3 setups due to the long distance from benchmark 1 to benchmark 2. Setup number 1, setup number 2, and setup number 3. B and D are the change point, connecting your setups from setup number 1 to setup number 3. This is the same example we have done with the height of collimation method. So this is the complete table after we finish the calculation. So we've seen the steps will include booking, means you need to record all of the readings from every point here and transfer to the leveling sheet. Each of the row over here will use for each point. Start from the first point to the last point. So then you do the calculation to calculate the reduced level of every point. And then we need to make the correction to calculate the adjusted level. We are going to see the steps in details in the next slides. Before you can do the calculation, you need to remember the principles of booking. So we need to know the definition of a backside. That is always the first reading after you set up the instrument. For example, setup number 1, the first reading is the backside to benchmark 1. A foresight is the last reading for that setup. We then rotate the telescope and take the reading at point A. And then you take another reading at point B. After that, you move the instrument to the next setup. So the last reading is the reading to point B before you move the level to the next setup. So the reading to point B in this case will be the foresight. So reading to B, this is a foresight in this case. And the reading to the benchmark 1, that is the backside reading. And the intermediate site, that is the point where you only take one reading. And you see that it's not a foresight and it's not a backside. It's not a foresight, it's not a backside. So that is the intermediate site. In this case, the reading at point A, because that's not the first reading after you set up the instrument, it's not the last reading before you move the level to the next setup. So we can easily see those points in the diagram here. Those are the points in the middle of the first point and the last point of the leveling run. The points in the middle of benchmark 1 and benchmark 2, but they only have one reading, as point A and point C over here. They are not qualified as the change point. We're going to go to the next steps. Now, let's look carefully at the procedure. The first thing we need to write the readings for every point. We do the same way as the height of collimation method. Point 1, benchmark number 1, the reading is 1.717. You write in the first line here. And then move on to point A. Point A, the next row, the reading is 1.432. And then we move to point B. So the order is point 1, point 2, point 3. So we write in the row number 1, number 2, number 3. A foresight reading at point B. So then we move the level to the next setup over here. And again at point B. So we have another reading that is the foresight reading back to point B to start setup number 2. So we write the backside reading here at the same line because they are the results of point B in row 3. Move on to point 4. Point C here you have the reading of 2.272. So then row number 4, 4 point C. Next point is point D. You have the foresight reading, and then you move the level to the next setup. After setting up, you take the backside reading still at point D. So you have to write the reading at the same line. Last reading is for benchmark number 2. So we have to follow the order of the survey when you write the results. After you got the readings over here, let's have a look at how to calculate the rise and fall and the reduced level. Step number 1. Calculate height difference between 2 points. Start from the first point. Height difference equal to the reading from the previous point minus the reading from the next point. So in this case, that is the backside of the first point minus the reading at the next point. So backside minus intermediate side give you these results. When the height difference is positive, it's a rise, an increase in the elevation. You write to the rise column over here. It means it's a positive value. Step number 2. Once you have the rise or fall from point 1 to point 2 in this case, the reduced level is calculated. The formula is reduced level of the point unknown equal reduced level of the point known or the previous point plus the rise or minus the fall. In this case, reduced level known plus the rise over here give you reduced level at the next point. It's 29.515. So that's the principle. Very simple. Calculate the rise or fall. The first step. Step number 2, reduce level unknown equals reduce level known plus rise or minus fall. And then you repeat this process for every point of the leveling run. In this case, calculate rise or fall of the next 2 points. Now we move from point 2 to point 3. So the reading from point 2 is this much, 1.432. then minus the reading at point 3. So remember to follow the process over here. The foresight here is the reading you take at point 3 before the other reading over there. So this reading is for the next setup. So the direction is going to be from the left to the right. So never go backward. Take this reading and go backward to the backside reading here. So you do it this way. So we have 1.432 minus 1.716. That gives you the results over here. It's a fall because the result is negative. So you put it here. So then the reduced level of point 3 or point B in this case, take the non-elevation here minus the full value. So then you are going to get the reduced level over here 29.515 minus 0.284. So we write it down here. And then we repeat this step for the next setup. Once you see another backside reading here, it means you move your level to the next setup and you take a new backside again for the new setup. So then we repeat the process from point 3 to point 4 in this case. It means from point B to point C. We repeat this process. So from B to C, we have the rise or fall. It's going to be the backside reading again minus the intermediate side, the reading at the next point. So here you will have 2.918 minus 2272, 2.272, and that's going to give you a rise or fall. You check that result. So we then write the results in here. And then calculate the reduced level from the known elevation of the previous point, plus the rise or minus the fall in this situation. So that's the process. We're going to see the whole results in the next slide. The next step is to do a calculation check to make sure we have done the calculations right. So now let me just quickly remind you how you can get the reduced levels of each point over here before we do the calculation check. From benchmark 1 to A, so what we did is calculate the rise or fall from benchmark 1 to A. So backside minus the intermediate side give you a rise, and then you use the known elevations here minus the rise here, that give you the new elevation of point A. From A to B, the rise or fall 1.432 minus 1.716, that give you a negative value, so that would be a fall. The known elevation from A minus the fall over here give you the new elevation at point B. So then we move to the new setup and we take the backside reading at point B and the fall and the intermediate side at point C. So we have to go back to the backside here minus the intermediate side to calculate the rise or fall from B to C. So it is a rise because it's positive. So use the known elevations of the previous point plus the rise that give you reduced level of point C. From C to D, 2272 minus 0.953. So that gives you a rise of 1.319 meter. Reduced level of point C is known right now, plus the rise here give you reduced level of point D. So once you see the backside reading here, it means you move to the new setup from D to benchmark 2, and you take the new backside reading, and then you go to benchmark 2, you have the last reading here, which is the foresight. So 0.816 minus 3.005, that gives you a negative or a fall value 2.189. From D to benchmark 2, known elevation minus the fall give you the elevation of the benchmark number 2. Normally it's not going to be equal the known elevation of that benchmark, due to we always have some errors due to the instrument errors, natural errors, or personal errors. A few millimeters is acceptable. In this case, we're going to explain it in the next slide. To make sure that we have no mistakes in the writing or calculating these figures, we can check for the errors. The same way we did with the height of collimation method. So now use the formulas for the calculation check. Sum of backside minus sum of forward sides. So the back sides over here have the sum of 5.451. The sum of forward sides, the forward sides over here have the sum of 5.674. That gives you a value of minus 0.223 of the calculation here. So move on to check the sum of rights. So you have 1, 2, 3 values here with the sum of them 2.250. 2 values for the fall over here give you the sum of 2.473. And the result of the subtraction is 0.223, the same as the sum of backside minus the sum of forward sides. Another check we can do is the reduced level of the last point minus reduced level of the first point. So we have them here. Benchmark number 2 after calculation, the last point minus the first point here. So then you have the same value as the other calculations. So it means you've made no mistakes in the booking and calculation of the reduced levels of every point for this leveling. So now move on to the calculation of the misclose of the leveling run, and compare that misclose with the allowable misclose or the maximum value using the given formula. So in the next slide, we're going to see the example. In this example, what is the misclose of the leveling run? So the last point here is the benchmark number 2. So the observed value or the measure value is 29.007, and previously the reduced level is known, or the true value is 29.001. It is the benchmark, so we know its elevation before we do the leveling run. We will calculate its reduced level to compare with the benchmark elevation to check for the error of our leveling. So in this case, the difference between the observed and the true or the known value is the observed value minus the known value. This elevation minus 29.001. So that gives you 6 mil. We have the same results as the height of collimation method as we have seen before. Here I just repeat the process. The limit 5 millimeters here times the square root of the number of setups. The number of setups, calculate from number of backside. 1, 2, 3. You have 3 setups. You can easily see from the diagram here as well. Setup number 1, number 2, number 3. So this formula gives you 9 millimeters limit, and it can be seen that the misclose is smaller than the maximum misclose allowed for this leveling run, so it is acceptable. If the misclose is larger than the allowable misclose over here, the results are not accepted and you have to do this leveling run again. Distribution of the misclose. Once the misclose has been found, it is necessary to distribute this misclose evenly throughout the level run. We assume that an equal amount of error has been made after each setup, and therefore the adjustment per setup equals the misclose divided by the number of setups. We are going to see an example in the next slide. Now we can see the example of the distribution of the misclose for the leveling run in the rise and fall method. Once we have the reduced levels of every point, we do the same thing as we did with the height of collimation method. There's no difference. So we can see it here. Step number 1, we've got the misclose of this leveling run. It's 6 mil due to the difference between the observed and the known values of the benchmark number 2. So we need to minus 6 mil to bring the observed elevations here down to the known value. So minus 6 millimeters for the last point at benchmark number 2. At benchmark number 1, where we start the leveling run, we keep the same elevations here throughout the calculation, then there's no correction. So 0 for the first setup and 6 mil over here for the last setup, or setup number 3. So it means each setup over here, the error is going to be 6 mil divided by 3 is going to be 2 mil, and we need to subtract this value for each setup over here. So now let's look carefully. The first setup, we minus that adjustment, so we minus 2. Minus 2 for the first setup. So you have benchmark number 1 and A and B. Benchmark number 1 is already correct, so no adjustment for that point. Reduced level, the observed value, and you add the correction, in this case -2, so that gives you the adjusted level, the final level after calculation, 29.513. And the next point, -2 mil from the observed value, 29.229. So you -2 for the readings of the first setup over here. So remember that the error is cumulative, so that's why it increased from 0 to 6 mil over here. So when we do the adjustment, we also do the corrections here cumulatively. It means the first setup we -2 mil. The second setup we will add another 2 mil to the correction. So it's gonna be -2 and minus another 2. So you have -4 millimeters for the second setup here. So from here to here, that is -4 millimeter. So you will have point B, C, D for setup number 2. Point B we already corrected from the previous setup, so we just keep it there, -4 and -4 for the next setup. So then the result is going to be 29.877 minus 4, so 873, and here 31.192. So then you move on to the last setup. So remember that you already add -2 from the previous setup over here, and now we add another -2 to the third setup here. So you have -6 millimeters correction. So exactly the misclose that you have for the benchmark 2. So that's why I give you the formulas here. Setup number 1, 1 times 2. Setup number 2, 2 times 2. Setup number 3, 3 times 2. So 2 mil is the adjustment for each setup, but you need to times that amount with the number of setups when you do the correction. Finally, you complete the booking and deduction to calculate the reduced levels of every point of this leveling run, and you made the correction to allow for the misclose error, and you distribute the errors here evenly for each setup. And you can see that after the calculation, if you make it right, you will have the same elevations of the first point here, benchmark number 1, and the last point here is the benchmark number 2. So this is the adjusted level, the same as the known value. Adjusted level, the same as the known value. So, congratulations! We have finished the calculation of the leveling results using the rise and fall method.